All right, so this section we're talking about the alternating series error bound. Okay, so looking at this alternating harmonic right here, so we have -1 to the n plus 1 all over n. So you see if I plugged in n equals 1, we're going to get the value of 1 and the decimal evaluation of 1. And then if I take, that's a1 would then of course just be 1. A2 would then be -1/2. And if I add these two, that gives me the sum 2, which is going to be a1 plus a2, which would be 1/2. And you can see right there, that's where our sum of the first two terms are. So I wrote out the first 8 terms. And you can see, in fact, that they are alternating. We've got positive, negative, positive, negative. So you see, in fact, it is alternating. And you can see our sum formulas, our sums are going to get closer to, it looks like 0.6 something. It was at 0.5, then it went as far as 0.83, then it got closer. And basically what's happening here is that these sums are going to the natural log of 2, which again, you don't need to know that. And that's the error. The error, you see, the error, which is the full sum minus the partial sum, the errors get smaller as we go on because our sums are getting closer and closer to that value. Now, in general, for an alternating series, the error is less than the first omitted term or the remainder. Okay. So if you think about that, let's just write out a simple little sequence. So if we had 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, wherever I decide to chop it off, the biggest the error could be in absolute value is the first term that we omitted, because we're going to add a little bit, then subtract a little bit, and add a little bit, and subtract a little thing. So this, the absolute value of the first omitted term, talks about the error in the approximation. So in the first problem, we want to know how many terms we need to get the error less than 10 to the -3, or 1 over 10 cubed. So I would look at each term. Is this less than 10 to the -3? No. Is this less than 10 to the -3? No. So we'd keep going. But what we need is 1 over n to be less than 1 over 10 cubed. So it's going to have to be bigger than 1,000. The second one, we want to know the error in the approximation for the first 10 terms. So if we're using 10 terms, the 11th term is going to be the error. So you can see right here, if I'm plugging in the 11th term, we plug in n equals 11, and it's in absolute value, so it doesn't matter if it is positive or negative, but the error of that approximation, keeping the first 10 terms, is less than 1 over 57th. Same thing here, we have this going on here. We want to know what the alternating series values are for the first 5 terms. So we go through, here's our first 5 terms, and that would be our sum. We want this approximation to be less than this. Approximate f of 1 with error less than that. So how many terms did we keep in our approximation? We kept only those first 2 terms. So our error in the approximation is going to be the first omitted term. But what did we plug in for x? We had to plug in x equals 1. So looking here, this is going to be the maximum amount of error because it's an alternating series. The error is the first omitted term. So my first omitted term is 1 over 5 factorial because we plugged in x equals 1. So there's the error in that calculation.